not have enough time. Okay. Okay, thanks and good morning. Welcome back to this second session of training regarding EDIAQI, dynamic data interoperability. This session is part of the task 4.3 of the EDIAQI project. This is the second session. In June 21st, we had an introduction basically to SensorThings API standard, following this path, this agenda. So we took a presentation of OGC and also data interoperability concepts. Then we jumped into the standard itself, talking a bit about the SensorThings API, looking at the data model to the APIs with some examples of requests related to the classes defined by the standard. So location things, data streams, multi-data streams, and observation. Then after the coffee break, we started to talk about software implementation of the standard. In particular, we started to focus on Frost, that is the focus of today, by briefly describing its characteristics, the possible options for deploying, the components behind, and we anticipated the possible evolutions of the standard itself, the SensorThings API standard. For instance, the so-called STA Plus that Luca described briefly, mentioning the possibility to use such standard also for citizen science initiatives. Then we finished the session looking at the Inspire directive that is somehow recalling also SensorThings standard for accessing and downloading dynamic data. So all the materials of the first session are already available on the EDIAQI project website at the URL that you find here at the bottom, or you may also get the same link with the QR code. Okay, today, apart from Deda Next staff, we will have, hopefully, because I don't see him yet connected, Dr. Hylke van der Schaaf from the Fraunhofer Institute. He is the project coordinator of Frost open source solution implementation. And the aim is to start with him with a description of the reasons that brought the Fraunhofer to implement Frost, possible and upcoming evolution of Frost, and also the idea is to showcase some live demos already running and operational in Germany. We would like to reserve some minutes, few minutes, let's say no more than 10 minutes for a brief roundtable, collecting some possible questions or comments from the audience to Dr. van der Schaaf. And then we will open the more technical part of the session with Luca describing a real example of deployment of Frost within Tomcat. In the example is related to Ferrara. So Luca will explain what we already did in the case of Ferrara, in the municipality of Ferrara. I see now Hylke van der Schaaf joining. Hi Hylke, good morning.
Hello, I finally found the URL.
Okay, good. So I was introducing just the agenda for today before leaving the floor to you. More or less at 10:30, we plan to have a half an hour coffee break, and then start again at 11 o'clock. Martina will briefly describe how to deploy Frost within Docker. And then we will have, again, some practical examples of data ingestion using Wi-Fi, using Apache NiFi, examples already undertaken in Ferrara, not only related to air quality domain, but also considering other dynamic data from other domains. This is an error, of course, in the time slot between 11:45 and 12 o'clock. We would like to start a discussion with the EDIAQI partners regarding possible semantics of indoor air quality data, and then have the final slot for feedback and also for discussion about possible timeline for deploying a SensorThings compliant solution at the pilot level. So the idea is to have some input from lab service, THINNECT, and Wings. Okay, I leave the floor to Dr. Hylke van der Schaaf. I am closing the sharing of my screen.
And I will try to start sharing.
Okay. Yeah, Hylke, you may find a sort of north arrow. Okay, something is appearing. Please, the floor is yours. You may have 25-30 minutes.
Yeah,
okay.
Should work out. Thank you.
Thanks.
Right. So
Ecco,
Giorgio
trovato
asked me
tutto. 2010.
to
Flash
tell
crash
you
del
this
2010.
Invece quello che ti dicevo
Sorry,
io,
I kindly ask everybody that is not.
un film, Dumb Money.
Ah, è vero.
Okay, that look like this. Okay.
Thank you.
Sorry, there was some noise. Yeah.
Giorgio asked me to tell something about the history of Frost, why we did it, why we built it, some of the features, and some examples. So why did we build Frost in the first place? Well, basically because we needed it ourselves. So back in 2015, we finished the Open IoT project, and the software that came out of that didn't work as well as we hoped, mainly because it didn't have a nice REST API. And for a follow-up project, we did need some software to store IoT data that actually did work. And right around that time, end of 2015, the SensorThings API version 1.0 was being finalized in OGC. So we figured there's no open source server yet implementation, so let's build one ourselves. So why make it open source, and why were we looking for an open source server? Well, Fraunhofer IOSB, the research institute I work at, is a research institute, and it's our financing is mainly through projects, both European projects and industry projects. And for us, it's important to be known as the experts in the field. And we're also not in the business of selling software. We're a research institute, not a software house. So for us, it made no sense to build something and then try to sell it. It makes much more sense to have it as open source, so everybody can use it, and everybody can see that we're experts in the field, and that helps us then find more project partners. So why did we use open source, specifically the LGPL? First of all, using Frost is always okay, regardless of what you do. Then you can also use Frost as a library in a closed source project. So there are actually companies that integrate Frost in their product that they then sell and sell support on. But if you want to change something, then you have to release your changes as well. So you can use Frost as is in any way you like, but if you change something in Frost, then you have to give back those changes back to the community. So a little bit of the history. So we're already working on this for 7 years now. Time flies. We started beginning of 2016. And back then our goal was to make a full implementation of the SensorThings API. So in July, we published our first version on GitHub. And then still in 2016, in November, we released version 1.0 that could do all the create, read, update, delete, data arrays, and MQTT bits. Shortly after that, we also added the multi-data stream support. And then, well, JSON filtering was added in the next year, Docker support added. 2018 brought us flexible identifiers, so you're not stuck to just using numbers for your identifiers, but you can also use strings or UUIDs if you prefer. But all the way up till February of 2018, we didn't really have a good name for the project. Naming is always difficult, so it was just SensorThings-Server. But in 2018, in February, we settled on the name Frost, Fraunhofer Opensource SensorThings. And also in 2018, we added batch processing, and with that, we had the goal, our full implementation of the SensorThings API. But of course, development didn't stop there. So we added in 2018, the city of Hamburg contacted us. They needed to be able to store a lot of data, and that's when we made Frost horizontal scalable. So you can add many Frost instances next to each other, and they can work together. In 2018 as well, the local university KIT needed a way to be able to specify the IDs of entities themselves, so they could sort of import them from an external source and still have the IDs the same. So that's when client specifies IDs were added. We get Helm charts, authentication. Actuation was finished in 2019 and also implemented. So that's the actuation specification, so you can send commands to sensors or to actuators. Then thanks to BRGM, the French Geological Survey, we added CSV and GeoJSON support. And then last year, we released version 2.0 of Frost, which added a lot of major changes, but the most important one is that the data model is now completely flexible. So Frost itself is just an empty shell, and you can add a SensorThings data model with extensions or your completely own data model if you prefer. We also added initial OData support. And an important performance thing is that Frost now directly streams data from the database. So if you do a request for millions of observations, it doesn't first load them and then send them. As soon as the first one is loaded, it's directly sent to the client. So Frost memory use is really minimal thanks to that. And the most recent feature is that we now also have fine-grained authorization. So you can actually, it's not that easy to set up yet, but you can specify that a certain user can only change data on certain data streams or on certain things. So there's still more changes in the pipeline, even though it does support the full SensorThings API. So some of the important features of Frost, data type handling. The SensorThings API says that the observation result is type any. That means any valid JSON. So that can be numbers, it can be strings, it can be complete objects or arrays, but also Boolean numbers or even explicit null. You might say, why do you need a null as a value? But in some domains, it's important to know that you try to make an observation, even if you didn't actually get a result. And then you can say, well, I made an observation or I tried, but the results didn't work out. So I specify that as a null. And in Frost, that also all works. So it's truly type conserving. It also, when sorting, it sorts by the types. So if you sort, you generally also get the numbers sorted as numbers and then strings sorted as strings. Because if you try to sort numbers as strings, you get weird things that 11 is bigger than 2, or 11 is smaller than 2. So you get 1, 11, 2. That's of course not what you want. And an important one is Frost is precision conserving. So if you send the number 2.000, because you made a measurement to that precision, it stays 2.000 or how many zeros you want. So you can get it back exactly as you put it in. So identifiers, numbers, just numbers is often not enough. There are many use cases where you need, for instance, to have your things with a UUID or a string ID because it's semantically more useful. So in Frost, you can specify for every entity type what the primary key type is. And you can specify also per entity type whether a user is allowed to set the primary key or whether the server has to generate it, or whether it's both allowed. Frost can do really nice complex filtering, especially also with times and intervals. So you can do actually calculations with time. So you can, for instance, say, well, I want to filter by the phenomenon time, but I want every phenomenon time that is greater than now minus an hour. And that means you've got a static URL that doesn't change, but every time you execute it, you get just the last hour. So your results will change, which is in dashboards, for instance, very nice because your dashboard doesn't have to do calculations and try to put the correct date into the URL. No, you have a static URL and that always gives the last hour of observations. Also interesting is that you can compare, when filtering, you can compare not just to constant values that you supply, but you can also compare to other values in the server. So you can, for instance, filter observations and compare their result to a value that you stored in the data stream. So if you have a threshold above which a warning needs to go out, you can specify the threshold in the data stream and then actually filter and say, compare the result value to that threshold. A reasonably new thing in version 2 is flexible data models. So you can actually extend the data model to fit your domain. And in almost all cases, you can do that in a way that is backwards compatible to Frost. So this is a small example of the soil domain. We took the Inspire soil model, which is this green bit here, as specialized things. So they have all their specific relations that are important for the domain. And attached to them are data streams and, of course, locations to see where these entities are. And we mirrored all of these locations in the things. So we've for the SensorThings, for a standard SensorThings client, still has a things entity type that it expects. So a standard SensorThings client can actually display the data and use it. But the domain client can actually fully use the domain specifics relations, that the soil profile has soil horizons, and do queries on that. So you get the best of both worlds. Here's another example from geotech. That's currently an interoperability experiment that is currently running in OGC. And BRGEM is leading that, and they asked us to do a Frost implementation. And here we added sampling because SensorThings version 1.1 doesn't have sampling yet. So we've got our things here, and in blue is the standard SensorThings model, and in green are the bits we added for the geotech domain, and in yellow we added bits for security and user management. Right, deployment, every use case is different, so we've got quite flexible deployment options. Some users directly deploy it themselves on the Tomcat, but most users use Docker, either directly using the Docker images or using Docker Compose, or using the Helm charts we distribute. And that gives you a highly flexible environment where you can also easily horizontally scale your setup. You can try it yourself in 3 simple steps. I'm sure that will be part of the later presentations. Scalability, so FrostCan is horizontally scalable. It's based on a Postgres database. Postgres itself is scalable, so you can make a Postgres cluster on multiple servers if you need to. Then you can start a message bus that uses MQTT in the background. And then you can have multiple instances of the HTTP and MQTT instances, depending on your need. If you don't use much MQTT, but a lot of HTTP, you can have multiple HTTP instances. Or if you need lots of MQTT users, you can have multiple MQTT instances. And they communicate over the message bus to notify each other when an entity changed, so that all the MQTT instances can actually send messages when needed. A few performance numbers. Our highest volume user at the moment that we know of is the city of Hamburg. They are pushing about 2,000 with peaks to 5,000 observations per second. That's mostly traffic light data. They've tested, and in tests they managed to reach 40,000 observations per second, which is a lot. They don't store that very long, about a week. And they're running on an auto-scaling Kubernetes cluster in Microsoft Azure environment. We ourselves run an air quality demonstrator, where we copy air quality data from the European Environmental Agency. That's about 12,000 observations per hour, which is still about 3 to 4 per second. But compared to 5,000 per second, that's nothing. And here we store it basically forever. So that's about, currently we have about 700 million observations in a surprisingly small setup. So it's just, we run it on our test Kubernetes cluster. It does have an SSD disk, which is the most important bit for the database, but it's just one HTTP instance and one MQTT instance on a cluster that is shared with many other projects. And that currently gets about 4 million hits per day. So some use case examples are air quality. It's an outdoor air quality. We harvest from the EEA air quality for all European countries. They're obliged to provide the data. And the EEA makes it available as hourly averages. And we've got data since 2018 that we imported, and that's currently about 700 million observations for about I think 12,000 measurement stations. One cool thing of the SensorThings API is that your location or your feature of interest can be any GeoJSON or any feature actually. That's not just points. So in this case, we've got an example with rivers. It does actually have measurement data. Basically, it's just feature data, but each river also knows which river it flows into. And so you can follow the streams. That's about 20,000 rivers for the country of Baden-Württemberg, which is where we are. This is Karlsruhe. That also works surprisingly well. My favorite example is always the urban data platform of Hamburg, because they also have live data. Let's hope the map works. So they store live traffic light status. If it works, it says still a test setup. It's not doing much at the moment. They might be playing around with it, or they might have some issues. Well, we can come back to that later. Always fun live data, live demos. But basically, you can see all the traffic, the lanes, and colored by the lights they're stopped for. So, and that then changes in real time. A very recent one is the mobility dashboard of Aachen. I don't know exactly, I haven't looked at the data in detail yet, but they've got a nice dashboard with like parking availability, bike landing places, car charging stations, weather, and some other things. I don't know exactly which things they store in SensorThings and which are coming from proprietary APIs, because some of it's not of the city itself. An interesting one is that they're technically not SensorThings compliant because they remapped their URLs and they no longer have the version number of the SensorThings API that they use in the URL. And the standard states that you must have the version number in the URL. So that's something to pay attention to. Also, a recent addition is STA Plus. That's a new data model extension that's currently under vote at the OGC. Vote should end in about a month, I think. It makes a SensorThings API for citizen science. So it adds some extra entities that are important for citizen science, like the party, because every citizen owns its own data. So you need to know, well, who made the observation. And the license, because if you don't know the license, you can't give out and use the data. So that's a very important one. And then there's, because this was for initially developed for species observations, and they also have things like relations and groups. So if somebody makes a picture and says this is a frog, then somebody else can make an observation on that picture and say, well, that's not a frog, that's an elephant. And then somebody else can say, yeah, I've been to Africa, that's clearly an elephant. And all those things can then be stored using relations in groups. And then they've added a project which will probably be renamed to campaign, in cases that there's a measurement campaign and many citizens go out in context of that campaign to look, for instance, for a specific species or in a specific area. And then also a new feature is fine-grained security. So we often had the question of whether we can limit a user, for instance, to only insert observations in certain data streams, or where users can only edit entities linked to a certain project, or whether we can specify that users can only read certain observations. And in the core, Frost can now do that. It's not the easiest to set up yet, but it does work. So one example, prototype example of how that could be set up, because it's very flexible, is, for instance, in blue is the SensorThings data model. And in this case, we have added a project entity that is linked to things. So a project can have multiple things, and a thing can be part of multiple projects. Then we've got a user with a username and password, so they can log in. And there are roles, and a user can be linked to a project in a certain role, and that's the user project role entity type. And using this, we can, for instance, say that, well, a user can only insert an observation if that observation is in a data stream or will be in a data stream that is linked to a thing that is linked to a project where this user has the role needed to create observations. Or another example is, for instance, you could add a flag to a project that it's not a public project. And then when you fetch observations, you can specify, well, if a user fetches observations, you have to check the data stream, the thing, the project, and either that project must be public or the user must have a certain role in that project. And only then can he get that observation. Now it's very flexible, very powerful, but not easy to set up yet. It's also very new. So what do we do as Fraunhofer IOSB with Frost? We are, of course, always looking for to partner in European projects or other projects. We offer support online or on site, like introductions to the SensorThings API, classes on how to data model your use case, or technical support in running Frost or optimizing Frost for your specific use case. And we can all, of course, be contracted to build custom extensions, like BRGM that sponsored the CSP and GeoJSON extension, and several clients chipped in to do the fine-grained security bits. So that concludes my presentation. Are there any questions?
Thanks, Hylke. Thank you very much. Let's collect some any questions or comments from in particular EDIAQI partners. Mario, please.
Yeah, first, thank you for all the great work. So we plan to use it heavily in the EDIAQI project, and I'm really happy that someone did all the efforts to create this infrastructure for Europe. My question is related to kind of other projects, etc. Do you is there kind of like a pricing you have to provide your services to add I don't know, sensor providers or citizens to your network, or how does it work?
Well, we don't host any instances ourselves. But there are already several hosting providers that can also offer specific support for Frost. So most of the time, citizens or cities already or communities already have a hosting provider where they contract to provide their services and server support. All depends on the specific situation. We tend to, depending on the client, we offer basically hourly rate or daily rates, and we offer support contracts for this many days in a year, and that can then be flexibly requested when needed. That's usually the use case for support contracts.
And my second question is, how difficult is it for kind of amateurs or citizens to apply these standards? Is there like a tutorial? Sorry.
Yeah, there are quite a few tutorials. One of them we made for the API for Inspire project. I can post the link of that in the chat. There.
The Inspire project, is that the one where the city of Graz is also a partner?
No, that was not with the city of Graz. This was API for Inspire. We were contracted together with DataCove by the European Union to evaluate whether SensorThings API would be suitable for Inspire. And part of that was to also create some documentation on how to use SensorThings API. So that's where this tutorial comes from. But there are lots of resources by now on the internet on using SensorThings.
Yeah, I just add for those of you that were not connected last time, Inspire is the European directive for implementing an infrastructure for spatial information all over Europe. So it is an environmental directive dealing with geographical data, environmental data for many topics, for many domains. And we mentioned last time in June, very briefly, we introduced also what Inspire is in terms of not only directive defining principles, but also we mentioned the regulations and also the technical specifications. And as mentioned by Hylke, yes, there was a big project where Fraunhofer was involved for, let's say, demonstrating the maturity of the SensorThings standard, also for environmental related data falling within the Inspire directive framework. If there aren't any other question from other participants, I have one that is, of course, related to EDIAQI project that is on indoor air quality. As anticipated, at noon, more or less, we will have a brief discussion also about how to manage locations in indoor context, in indoor environments. So the very first question is a general one. Do you have any suggestions or hints for managing properly locations? And in particular, are there any examples of SensorThings API coupled with data models for buildings?
I don't know of any public endpoints that do that, because the problem with indoor air quality is that it can be privacy data sensitive, because in IOSB at our work we do also measure indoor quality, and there you can actually exactly see when somebody comes to work, because that's when they open the window and then suddenly properties of the air change. So you can see the temperature usually drop, or the air quality becomes suddenly better because they open the window. So you can't, you have to be very careful when you make data like that publicly available. And so in most cases, that data is not publicly available. I do have, of course, suggestions. This is actually a use case where a data model extension is very beneficial, because you will probably want to model your building and the rooms in your building. And of course, you want to see which room is in which building. And you could model that all as things, and then have in the properties the ID of the building for the room, and maybe a list of rooms for each building. But that's kind of hard to maintain. So it's much easier if you have actually dedicated entity types for your rooms and your buildings with actual relations between them. And then you can mirror those as things, so that the things are automatically synchronized with the buildings and the rooms. Yeah, that's such a setup can work very well. But it also depends on what exactly the goals are, and how many sensors you will have in a building, and which rooms. And
yeah, there will be a mixture of use cases, but also of situations with indoor air quality stations that could be installed in different levels of buildings. So not only in different rooms and building parts at the same level, but also in different levels. That's why I was asking if you are aware about possible connections between SensorThings standard on one side and other standards from OGC on the other.
Yeah, exactly. Yeah, Volker, of course, sent a link back, and he sent you a paper, I think. This is actually also a use case where, because of that privacy aspect, where the fine-grained security can be very useful. So you can, for instance, if you have high fine-grained data, like every minute or so, you can make that non-accessible for the public, but only make hourly averages or even daily averages available to the public, because the privacy sensitivity is much lower, because you can no longer see exactly when somebody did something.
Yeah,
because it's smoothed out.
Yeah. Okay. Thanks once again, Hylke. From the audience, are there any further questions or comments? Otherwise, we may thanks again, Hylke. Of course, if you are willing to stay with us, you are more than welcome. Otherwise, you may leave.
Thank you.
And yeah, we are recording this session as we anticipated at the beginning. So all the materials, both the recorded videos and also the slides, will be made available on the EDIAQI project website. Okay, so we may jump to the second slot of this first half with Luca. With Luca Giovannini from Deda Next. And while Luca is preparing slides and screen, what we will start to see with Luca is a practical example of how we deployed a Frost solution in the case of the municipality of Ferrara within Tomcat. So Luca will mention some specific components and versions like Tomcat, Postgres SQL, PostJS, and Timescale DB extensions.
Yes, good morning,
Okay.
everybody. Can you hear me and see my screen?
Yes.
Yes, good. So as Pier Giorgio mentioned, I will describe basically step by step how we deployed Frost for the municipality of Ferrara, where we experimented it for for a real use case, and where we use it to collect all the sensor data that the municipality had access to. So air quality data on one side, but also data about traffic and other kinds of sensors. So the first stop in order to install and configure Frost is, of course, the official website, where you have all the documentation that can guide you step by step. I will provide a step-by-step description of it, but of course the main source of information is the Frost website, and parallel to it, there's the GitHub repository for the code, where is that is the place where we should start to download the code. Before we start, we have to make a couple of choices. The first one is which of these three packages, which of three architectures actually we should choose. The Frost server is provided in these three versions, either with just the HTTP protocol, just the MQTT component, or both of them. As we briefly saw in the presentation from Hylke, they are meant for different use cases. And for the case of Ferrara, where there was no need for a big scalable architecture, we went for the MQTTP solution. So the one that I think I should have also exactly screenshot from the portal. So a solution where there is one HTTP protocol application and one MQTT application together in the same Tomcat package, and they are directly connected. So any addition, any data addition to the HTTP through the HTTP protocol is propagated to the MQTT that broadcasts it to whoever is subscribed. Basically, they are two ways of two protocols, two different protocols to interact with the data. MQTT is a subscription messaging system, so it broadcasts data as soon as it's added to the database, to all the entities, to all the people, to all the users that subscribed to the endpoint. While the HTTP endpoint allows for input and output of the data through APIs. That's the alternative architecture that you could build if you had different instances of the HTTP module and the MQTT module. This is meant for wider for situation where you need a more complex architecture. So we will go, and we went in the case of Ferrara for the MQTT solution. The second question, the second thing you have to decide is whether you install Frost server as an application in a Tomcat environment, or if you want to use Docker. Again, in the case of Ferrara, we chose the solution of installing it through Tomcat. So, first step is to deploy the WAR file, so the package for Frost server, to Tomcat. So here I tried to briefly summarize the steps so that you can actually use this presentation as a reference guide if you want to. So you have to install Tomcat, of course. Then you have to download the MQTT WAR from this from the repository, choosing the version you choose, you want to use, and then you have to add those two libraries and put them in the Tomcat library folder if they are not already there. Here I just summarized the specific version of those elements that we used in the implementation for the city of Ferrara. About Frost, we are now at the version 2.0 X, like more than 2.0, which has a lot of new features that Hylke presented in the presentation. But for the city of Ferrara, we started this work more than a year ago, and this was the version that was available then. I'm presenting this because I know this setup very well, and so I feel that it's safer for me to describe what I have personally tested, but I suggest you also to experiment the newer version because it has a lot more features, and we will ourselves do the upgrade in the following months. So the second step is to configure the database. The Frost application relies on a Postgres database. So of course you have to already have one or install a new one if you decide you want to have a dedicated Postgres database. You have to create a specific user that will be used by the Frost application. This is just the user password suggested for the initial installation. Of course, you can choose whatever you want. Then you have to create a new database. Again, you can choose the name you want. These are just standard default suggestions. And of course, you have to configure this new database so that the owner of this new database corresponds to the dedicated user that you have created. Then you have to be sure to have basically those two extensions, while timescale.db is optional, is actually an extension that we will see it in action in detail at the end of the presentation. We as Deda Next has decided to add it, to test it, to provide additional performance on the treatment of time series data, which is the core functionality of this extension. So again, these are the version that of this element that we have used in the implementation of within the premises of the city of Ferrara. Sorry, maybe I should describe a little bit more what those extensions are. The first one is basically provides the service of creating UUIDs, which is a standard way of creating IDs, string type IDs. The second one is a module that adds all the types and functions to Postgres that provide support for geometrical and geographical data elaboration. And the third one, as I was mentioning, timescale.db adds functionalities and optimizations to handle data that has a predominant dimension for where time is a predominant dimension. So it basically enhances the optimize the data reading and writing and aggregation for time series data. Then there is this the further step is to actually configure the Frost server application so that it adjusts to your specific situation. First of all, you have to let Frost know where is the database that should be used for the persistence of data. So you have to go edit this parameter file here that you find in the file system under, of course, the folder where you installed Tomcat. And then the first thing you have to configure is the JDBC resource, where you have to provide the URL to the JDBC URL to the database and the username and password of the user you created specifically for the Frost server application. Okay, and that's the the one that's most important of all. Otherwise, the application doesn't have a database where to store data. Then you can choose to adjust other parameters. I'm describing the ones that we decided to edit for Ferrara. So the first one is service root URL. it's the URL, the external URL of the application. So if you plan to expose the endpoint and made it publicly available to the outside, then you probably will map it to an external domain, and then it's very useful if you put this information about the external domain into this parameter, so that automatically all the links that all the links to the elements internal to the database are updated with this external endpoint. Then there's parameters that define how many the volume of data that's outputted by the API when you request data, and that might be useful, might be something that you want to change to adjust to what your server can provide, and what are your expectation of how much you want to wait when you ask for data. And then there's these other two very important elements that decide the type that the system should use to define IDs of all the elements of the Frost entities. So location, thing, data stream, observation, every element of the model as an ID, of course. And you can choose here what type of what type to use, if a string or a UUID or a number to use to define the ID. This is proved to be very important and useful as a choice for Ferrara, because as some other use case that Hylke mentioned before, also us, we wanted to be able to define our own custom IDs to facilitate basically the human readability of them and the insertion of data. But apart from the reasons, we needed to be able to define our own IDs for the entities. So and we needed them to be strings. So we use this option to require that the IDs should be of type string. And we modified this last parameter so that the server allowed us, the user, to provide our own client-generated IDs, because the default mode is to is not to allow the user to insert IDs, but to have the system to generate them automatically. So those two parameters coupled allowed us to have control on IDs and to design them the way we wanted. So that's why I mentioned them. But there's more. You can find them in the documentation, and they help you adjust the functioning of the Frost server to your specific needs. Then again, there's a further step, the fourth step. Now, so we have downloaded the application to be installed in Tomcat. We have installed it in Tomcat. We have created a database dedicated to Frost in Postgres. We have connected the Frost application to the database and fine-tuned the parameters of the Frost application. Now, finally, we can tell Frost to create the DB schema in the way we have requested through the parameters. So in order to do that, you have to open a browser and go to the URL where the application answers. So we have configured it to appear at this URL, and you have basically these four choices. The first two will bring you to the endpoint of provided in two different versions, while the third one, database status and update, will bring you to a page like this, always in the browser, where you can press the update button, so that automatically the application will create the tables on the database in the database and schema that you indicated. So maybe this is time for us to jump to a real situation, the real implementation. So this is the database of the municipality of Ferrara, and we can see here that in the SensorThings database, in the public schema, these are the tables that were actually created when we pushed that button. And if you remember the structure of the SDA data model, you can find here basically all the correspondence to that model. So there's a table for location, there's a table for things, there's a table for data streams. Where is it? Here. And a table for multi-data streams, etc. And of course, there's also the tables that handle the relations between the entities. And so it's really straightforward. And for example, if we open the things table, well, actually, if we see the structure of the things table, you see that there is exactly what it is expected to be. So the identification, name, description, and the property field, which is the one, the extra field that allows you to add any additional information you might need. We have already talked about this property. So this is what you get, and of course you get empty tables. But you get them with a structure and the relations and the constraints that are required by the model. So let's go back to the presentation. Here we are. Once this step is done, you get to those tables. Then this is a side step that I decided to provide you anyway, because I think it could be useful if you decide to install that specific version. There was a little bug that we solved. So here I'm providing just the SQL script to correct it. Basically, when you add new observation data to the data model, there is a trigger function that updates another table to update the basically the value of the starting timestamp and the end timestamp of the describing the whole time period of data availability. And this add a bug basically, and this is the correct script. So if you are installing this specific version, then at this point you might want to run the script that will fix the bug. It's a very small problem, but since we encountered it and solved it, and since I'm describing the step for this specific version, I thought it was useful to provide this. But this is the side step. Then we're very close to the end of the steps required to prepare the setting for Frost application to work. This is an optional step. As I was mentioning at the beginning of the presentation, we decided to experiment with this extension, TimescaleDB extension to Postgres database, which is meant to optimize the handling of time series data. And basically what it does, you can apply it to any table of any schema you have, where you have one field that stores time data, so a timestamp data or a data type field. And what it does is it splits the single table into it transforms it into a hyper table. So it's a abstract table made up of a long series of subtables where the information about time is grouped in all those subtables. Basically, the data is ordered along the time dimension and subdivided in small tables, so that when you have to insert new data, all the action is done only on the subtable where the data fits. So the new data arrives, you check what is the timestamp of that data. The system checks what is the timestamp of that data and puts it in directly just on the table that that covers that interval of time where that data belongs to. And also, when you have to read it, you just work on one subtable at each time. So this is the basic of the optimization that this extension provides. In order to activate it, basically that is this line that you have to use. You have to call the create hypertable function. You have to choose the table where you have to apply it and the name of the field that stores the time information. So we applied it to the observation table and to the field phenomenon time start, which is the one that is almost always actually always filled with the time information, because if you are storing instantaneous value, then this is the field where you store the time of the measurement. If you're storing measurements that are related to an interval, then you store the begin of the interval in this field and the end of the interval in the phenomenon time end field. So the phenomenon time start field is always always as a value. So that's why we chose it. But in order for this command to actually be executed correctly, we have to remove the constraints of the principal key for the table observation, because that would be an obstacle for the creation of the hypertable. Basically, because the constraint of type primary key on a table requires that all the ID that the ID field of that table is unique, so that there's no two records with the same ID. And since this this function here, the one that splits the table into several subtables along the time dimension, is not able to enforce this unique constraint, because every subtable then can enforce a unique constraint on the ID on the specific subtable, but there is no way of enforcing a constraint on the ID over all the subtables. So that's why if you have a unique constraint, this function will not create the subtables. So since we want the subtables, we removed the unique constraint on the ID. We then create the subtables, and then since we couldn't add again the unique constraint, but we at least want the ID field to be optimized, we recreate an index on the ID field. And then we are not worried about the fact that actually the ID will be unique, because since just for the observation table, the ID is still created automatically by the system with by assigning a sequential integer to each new observation that is inserted. So the uniqueness is guaranteed anyway. It's just not checked by the system, but it's guaranteed by the way it is developed. So that was not a problem, while we were now able to enjoy the optimization of time scale. So this is what was described in the first remark. And the second remark is that this operation, the one of transforming the observation table into an hypertable, it's best done when the table is empty. Otherwise, it takes a lot of time, because the system, the database, has to reorder all the data along the time dimension before performing the hypertable thing. Then lastly, but not at all, but very important, is the security part. So now, if you want, you can. There's two last steps: the configuration of URL proxies, if you want to expose to make the endpoint, the Frost endpoint, accessible from the outside from a specific URL with a fancy name. then this is the time to do it. Of course, it has to be closely related to the one you have provided in the service route URL. It has to be the same, not closely related, but it has to be the same. But again, it's not that's not a necessary step. You might want to keep the endpoint internal, just for internal use. And then there's the SSL certificate, the one that allows you to provide access to the endpoint through HTTPS. Again, when you expose the endpoint, pay attention not to expose also access to this page here, to the database status and update, because I beg your pardon, because that would allow access from outside to the functionality that can recreate and erase and truncate your database. So be careful to expose just the two endpoints. And even more on this, I suggest you to explore the newer version, where there is a fine-grained system related to authorization, because there's also the issue of you might want to expose the endpoint publicly so that everyone, every user, every citizen can access to the data, but you might not want any person to be able to add or modify data that's already in the system. So you might want to have it publicly just for the read part, but not publicly available for the write part. And I believe this new improvement on the Frost server application allows you to do this. So if you envision this kind of situation, I suggest you to also explore this version, as we will do in the following months. And I believe that completes the presentation. I'm sorry it was not that fun, probably, but hopefully it provides you some hints and direction to actually install the system and test it. So if you have questions, I'm open to them.
Okay, thanks, thanks, Luca. I think that we may collect some specific questions from participants. So I invite all the participants not to be shy. And
okay, I open the webcam and the microphone so you can see me. I try Pier Giorgio and Lucas to break the ice. Okay, so to start a conversation, thanks to the father of Frost server, Hylke van der Schaaf, if I pronounce it well, and to look at Pier Giorgio to show how to implement Frost server. Let me say that this is an interesting point in the EDIAQI project, also for a SME company, because it gives us, all of us, a way to implement in an open source way a standard like the OGC SensorThings. So is an important point to get for all of us. We are guests now of the Ferrara Frost server. So we are starting now in the EDIAQI project by using the Frost server of Ferrara, but we are going, and we would like to implement it by our own. Okay, so my question for you is the effort. So from a pricing point of view to an estimation of time and of competency. So what we should ask for implement in the proper way Frost server.
Well, I can speak based on my experience, which is not null, but it's not infinite. Let's say I have basically installed two instances of that, one in our test environment and one in the municipality of Ferrara production environment. And I have to say that the installation by itself is very, very easy. And also, I've always worked on the Tomcat installation. I have very limited or no experience on the Docker installation, but my colleague Martina will tell a little bit more about that later. So just to contextualize, I'm talking about my two experiences related to the Tomcat installation, and that is really fast, the installation by itself. Then the area where competence is required is the configuration and the management of the database, of course, because you have to make choices related to am I going to need control over IDs or not? Do I need how should I what should I use? What protocol should I use to insert data? Should I work directly putting data on the database? Should I use the API to insert it? Should then is it useful for me to store the high frequency data and then create additional data streams for the aggregated data or not? So this type of choices require thought, experience, trial and error, and that's what takes time. But the solution, the software is robust and it's easy to install. So that's it's not that requires the effort, but it's the use of it that requires effort, meaning positive effort, that you have like use your creativity and design what you want. So I don't know if that answers your question, but
No, but yeah. Indeed, it's an open source way to implement a standard. So I appreciate look at that. You say that is easy to install and a robust infrastructure to work with. Okay, so the only things to do is the only thing to do, the only thing to buy is the server. So the host of the OGC open source software.
There's also yes, I'd say that's the biggest step.
Okay.
But then there's also to think about the security and access control part that I was trying to stress in the presentation. So you really have to think also on what type of access you want to provide and how to enforce it. I guess that could be part of the hosting, but also since some of the authorization infrastructure is now part of the Frost software, it's also part of the configuration of the system. So you might need some support also in the configuration of the application, not in the installation, but in the configuration and in the day-to-day management of it.
Just in case you will support us for some questions, okay? So not for implementing the software, but
yes, gladly. Yes,
okay,
no problem.
Okay.
But if you are requesting a commercial offer,
No,
then
no.
it's
No,
not
no,
me
no,
you
no,
should
no.
talk to.
No. It was just to have some tips and tricks from
Sure.
your side, okay, on which is the best way to do that. So it's a great chance from our side to implement it in the project with you and Hylke.
Thanks for having
Thanks.
broken the ice, Alessandro. You anticipated one consideration that I was I was thinking of when taking my notes. In EDIAQI, we will have different pilot areas having different characteristics in terms of sensors, in terms of technologies, but also in terms of context, in terms of also typologies and goals of pilot buildings to be monitored. So I think that we might collect some tips for, let's say, SensorThings API newcomers. And starting from what we already experienced practically in Ferrara. For instance, Luca, if you agree, we may here briefly say which were the troubles, if any, that we faced in deploying Frost in Ferrara, or we might also provide some characteristics of the Ferrara server in terms of RAM, disk dimension, or CPU. I think that these types of information could be helpful for EDIAQI partners, but in general for other STA newcomers.
Yes. So let me just prepare this kind of information. Here, yeah. So regarding your first suggestion of topics, so what specific issues we had in Ferrara? Well, the first thing that comes to my mind is not an issue, but it's an architectural decision, not architecture. It's a model decision we had to confront immediately. In the case of the municipality of Ferrara, actually, what's happening is that we are providing the municipality is using Frost not as a way to provide access to publish data that the municipality itself is creating, is measuring, but the municipality is just doing the job of like a data store. It's collecting data from external providers, like the regional administration has data about traffic sensor, and the municipality of Ferrara is going to the API provided by the region and harvesting the data about those sensors. Then there's the air quality sensor from lab service that are exposing data about air quality, and the municipality is going to that API and taking data, and so it's collecting data from different providers and exposing it through Frost, so through the SDA standard, so that anyone can access to them. And this is a use case that is probably not the primary use case for a single instance of the Frost server, because there's no standard way of separating the data, the streams, the data streams of the different provider, and that's why we had to resort to the property attribute that every entity offers, so that we could label the data streams related to the traffic sensors of the region, and label in a different way the data streams that stored air quality data from lab service, and etc., for the other providers. So there was no standard way, but there was a way, there was room for a customization through that properties parameter. So this is good. It's I mean it's an happy ending, but it leaves open the discussion on what if other providers choose a different solution for the same problem. So it leaves room for discussion. We could think of different solutions, and one possible solution is the implementation of SDA plus extension, because it was not meant for this specific use case. It was meant for data science campaigns, citizen science campaign. But the two use cases are similar, because in a citizen science campaign, there's again the situation where there's different data collectors that might collect different types of data with different sensors, and so there is the need to separate them in groups and projects, which is again the same, which is very similar to the necessity we had in the municipality of Ferrara. So we are thinking of evolving the current solution we found that was using the properties parameter, to evolve that and instead use the SDA plus structure, so that would make the solution more standard in a way. So that is one major decision we had to take and issue. And regarding instead the characteristics of the machine that hosts the service, I'm just retrieving them now.
Yeah, we may also provide them in the chat during the coffee break. But the idea,
I already have them. I'm
okay.
Pasting them on the chat. It's in Italian,
Okay.
but it's not very complicated, and I'll explain it. For historical reasons, for operating system, we chose CentOS 7, which is now out of support, but for historical reason we need to use that. Then we decided for a disk space that's not it's not small, but it's not very big either. Also, it's a little bit less than half a terabyte, but of course that can be expanded. We decided to gauge it depending on the volume of data that the municipality was actually receiving. And then we have a 8 processor core with 32 gigabytes of RAM. So I mean, it's very reasonable.
Yeah, I just remind that these characteristics were basically defined by the municipality of Ferrara, that within Airbrake project decided to have a unique instance of Frost deployed on a server already available. So the capabilities also of this server and also the characteristics in terms of operating system were somehow suggested or forced or driven by the municipality. And since I see Hylke still connected here, I would spend just a few minutes more, if he's listening, to highlight also with you, Luca, the main differences between the newer version of Frost compared to the one that you explained, that you just showcased related to the example of Ferrara. Maybe you can.
Yes. Yeah. I can. Well, if Hylke is there and wants to speak, of course, he has the precedence, because he definitely knows more than me about.
I always like to hear the external view. So go ahead.
Yeah. Well, I have to say, to be honest, that I have no experience with version 2.0. I just tested it briefly in less than a day. So I'm really excited about the new elements, and as I mentioned, we want to move to this new version because of its feature. I'm really interested in the authorization component, And the only thing that I think it's well, I think it's worth mentioning also here the fact that some of the elements that are provided bundled in the version 1.13 that I have experience of, there are divided in plugins in the version from version 2.0 onwards. So you have to like focus on the actual plugin that you need, and you have to activate them. And that's from my point of view, from like my being a user of the old version, that's the evolution step that I have to make. This one, and I have to learn, because it's really useful, the part about authorization. But I can only speak about my intentions, because again, I have yet no experience about the 2.0, so I can't really tell stories about differences, because I've not yet tested the 2.0. So I don't know if Hylke wants to add something more about the major differences, but he has already described the major differences in his presentation. So
yeah, one major difference that will be interesting for you, I can't remember exactly whether it's already in 2.1 or whether it's 2.2, is that you can specify per table what the identifier type is, and that I'm pretty sure that's in already in 2.0. But you can now also specify per table how the IDs are generated, whether they should be client supplied or server generated. I think that will be in part of 2.2 when I release that, but that should be pretty soon.
now that we're speaking of this, I actually have a question for you. I've realized that from a certain version on, there's a limit on the length of the ID, like 36 characters. I think. Do I remember correct?
That I don't know where that came from, but it could be.
Yeah. Okay. No, I will go deeper on that later. Yeah. I was curious about, because that I wasn't putting any limit on the IDs. So from a certain point on, I realized that there was that limit on in the version. So I just couldn't understand why. But that's a very specific question. I will maybe write to you about this later.
You can always change that, because if it's there, it would be a database thing, and you can just change the column type to have.
That's the trick I used, but I did. But yeah, thank you.
So what we may do in August time, before the next session that will be in September, is to prepare a very, very short document containing some potential useful tips and tricks to facilitate EDIAQI partners in the deployment of Frost with some specific tips related to what Luca presented, and also considering the newer version 2.x. So before breaking for a while, I would like to thank once again Hylke for his availability, and also for the interesting and useful presentation that he gave to us. Next, so the next steps today will be the following ones. Can you see my screen? So we will reconnect at the same link, using the same Teams link in 30 minutes, more or less, at 11 o'clock, with a brief presentation by Martina regarding the second example of deployment of Frost in Docker. Then Beatrice will talk about ingestion examples with Apache NiFi, again in Ferrara. And we will conclude in talking, or at least in starting a discussion that I think that will not end today, about semantics for EDIAQI indoor air quality data. So I thanks once again, Hylke, and we will reconnect in half an hour. We can switch off the recording of this video in order to split the video in 2 parts as already done in June. Okay, see you later.